اوكي. السلام عليكم. اهلا بكم في ويبينار جديد من سلسله الويبينارز اللي بنقدمها في الارب اي او تي اند اي اي تشالنج بالتعاون مع شركائنا. انا محمد ابو العنين، البروجرام مانجر للارب اي او تي اند اي اي تشالنج، وبيسعدني اقدم لكم النهارده باجوان هو الديجيتال ترانسفورميشن مانجر. ديجيتال تقريبا حصل مس كونكشن في الشغل. آه، نبدأ تاني المقدمة. مش عارف كان إيه آخر حاجة سمعتوها. إحنا النهاردة في الويبينار ده من شركة انتل بالتعاون مع الأرب أي أو تي أند أي تشالنج. ده مسابقة بتتم في الوطن العربي، وخلال الفترة دي بنعمل ويبينارز مختلفة أثناء فترة الحجر والستين ات هوم. فالنهارده هيقدم لنا السيشن باجوان، هو الديجيتال ترانسفورميشن مانجر في شركة انتل. السيشن النهارده عن الكمبيوتر فيجن. هنتكلم عن الاوبن فينو تول كيت، اوبن فيجوال انترفيرنس اند نيورال نتورك اوبتمايزيشن تول كيت. دي كيت بنستخدمها في الكمبيوتر فيجن ابلكيشنز. هيكلمنا عنها النهارده باجوان. السيشن هتكون بالانجلش، وهنحتاج والاسئله طبعا باجوان هيجاوب عليها في اخر السيشن. فاي حد عنده اي اسئله يقدر يكتبها خلال السيشن في الشات، وفي الاخر ان شاء الله باجوان هيكون بيجاوب عليها. Again in English, Baghwan will deliver the session in English. Baghwan is the digital transformation manager in Intel, and he is delivering this webinar today on OpenVINO Toolkit. It's the toolkit of Intel for computer vision. This session is part of our webinars in the Arab IoT and AI Challenge program of webinars during this curfew or lockdown period. Now I will let the mic with Baghwan to start the session. And please, before writing any of your questions, write your name, your country, and then your question. Thank you. Go ahead. You are muted, Baghwan. I will, yes, I will open it. Okay.
Thanks, Mohammed. Yeah, I couldn't do that myself. Thank you so much for this opportunity. And first of all, very hearty congratulations to the Arab IoT and AI Challenge team for kind of taking this initiative and kind of inviting you all. And first of all, thank you so much for your time. I know everybody is fasting, everybody's staying at home, yet you kind of chose this 1 hour to come over here and listen about these new products and innovative solutions, right? So I'll try to be I'll try to deliver an interesting talk today over here, and I'm sure most of you know the agenda, right? So I'll just kind of talk about it. It's 4 points. I'll talk about OpenVINO, some of the use cases which will be used in OpenVINO. I'll talk about the Intel DevCloud, which is how you can make use of the toolkits which I'll be talking today from the comfort of your home with just a good internet connection and your PC. And probably it should kind of ignite some inspiration for you to kind of do your future projects in the near future, right? So without further ado, but before that, let me just kind of take a step back and let me kind of give an introduction about myself and my background. So the audience is familiar, right? So my name is Baghwan Ramnani. I'm the digital transformation manager. I've been working with Intel for almost 5 years now, and I've been delivering a lot of different projects in the field of Internet of Things, smart cities, blockchain, and now I'm focusing on AI, computer vision, and smart city vertical, right? I am engineer by profession, electronics and communication engineer, but I kind of took formal project management training and I'm a PMP certified project manager, and I've been kind of working with different customers, different partners on the field in delivering customer expectations and project deliverables. And as part of this, I kind of try to work with all of the latest and trending technologies which Intel produces, and kind of try to deliver to the extended ecosystem, that is the academic ecosystem and the consumer or customer or corporate ecosystem as well, right? So today's topic is pretty much simple, right? How we can take computer vision and its related applications and all of the related toolkits uh, and kind of utilize it for yourself, right? So, so okay, sorry about that, and let's move ahead. Just a small notice and disclaimer. I had to keep it because my legal team advised for that, and the premise for the talk is pretty simple, right? Like we've seen AI kind of taking shape in a day-to-day life. Like before this whole lockdown and this whole work from home situation kind of emerged, AI was already kind of changing at a very fast rate, right? And we were talking about different use cases in different scenarios, right? And how we could utilize it. And just to kind of take emergency response teams, they were already handling real-time emergency and crime responses in a certain level, right? Obviously, uh, all of these verticals are doing some form or the other utilization of AI and computer vision, but then there's a lot more to improve upon. And I'm here. The whole purpose of this slide is to kind of give you an basic overview, because Mohammed mentioned that a lot of academic students would be joining us apart from the experienced developers as well. So I thought bringing this slide up would also give them an idea of how things operate in the real world and what all verticals are doing different things, right? So I'll just kind of spend a few minutes on this so that everyone is familiar what's happening, right? And moving on to the next segment, that is the energy segment, right? A lot of companies are working on maximizing production and uptime, right? On the education, we're working to transform the learning experience, right? It could be how you kind of how the student tracks from the PC. We've done something called Project Athena from Intel's perspective, where we work with partners to deliver better results and amazing PCs so that students have a seamless experience in terms of education. Talking about smart cities, we kind of working with a lot of partners to ensure safety, do more research, and kind of bring in more and innovative solutions as and when technologies kind of evolve. In terms of finance, we're kind of turning data into valuable intelligence, right? There are a lot of machine learning and AI-based algorithms that are coming in, which are kind of helping banks and financial entities to monitor all of those scenarios and see where they can utilize their models. In terms of health, uh, uh, nowadays this is becoming a bigger and a much important topic, because of the complex era we are living in now. Telehealth services are kind of increasing. You're getting active use of softwares, active use of AI-based technologies for diagnosis, for treatment, and all other use cases are coming up day by day to see how it could be useful for the health workers and the health industry in general, right? We've seen great intelligent transformation in the industrial segment, where factories are kind of converting to bigger and bigger IT infrastructure and OT infrastructure transformation changes just to adapt to the industry 4.0, right? Also, in the field of media, we're creating thrilling experiences. So I'm not sure if you guys are following the latest innovations in AR, VR, and the different games. And by the way, just a small plugin over here, we have something called Intel League of Legends challenge, right? So it's basically a gaming and a media experience, right? I will share more details with Mohammed, and he can probably forward it to all of you participants after the event. This is probably just for people who are sitting at home to kind of experience this, take part in those games, and enjoy their time as well. So coming back to the media perspective, we're doing a lot with our different partners. We're doing something great in cloud gaming era. We're doing something in AR, VR. We're doing in generation of graphics, right? So an interesting thing, I don't know if you, there was one movie, I cannot recollect the name of the movie. Uh, Sorry about that. We had kind of powered a lot of graphics, the CGI graphics for that movie, and the company Ziva Dynamics was using their AI-based models to generate graphics for a lot of animals which were kind of portrayed in that movie over there. So what they had done is that they had taken our Intel Xeon-based scalable processors and other processors. They had used Intel optimized libraries, and they had kind of run all of these things, all of their models on top of the latest technologies from Intel, and they kind of sped up the whole process of generating computer graphics much more faster than the traditional versions, right? Previously, they used to kind of create each and every topology of each and every animal, and it used to take a lot of time to render, to process, to create the graphics. But with the latest binaries, with the latest libraries, and the latest hardware, all of that kind of sped up their movement, and they kind of got their movie out in a record-breaking time, right? And also in retail, right? Stores and inventory is being transformed uh, every now and then, right? Earlier, if I talk about the career which I've been over the last 5 years, I've seen RFID, Wi-Fi technology, beacon technology kind of coming in, but now we're talking about computer vision and using camera streams and latest AI algorithms to kind of manage inventory, to manage people in the queue, to see how the experience can be enhanced. So a lot of these things are also happening, right? In smart homes, so smart homes is a pretty simple topic, and it's easy for the consumers to understand. So it enables homes that see, hear, and respond basically through the phone, through your mobile app, or any of your app through the computer browser. You're kind of talking to all of the appliances and devices in your home, so you can intelligently connect and monitor. And like if you're outside and you kind of want to come, or you're kind of on your way to the home and you want certain AC or lights or something to be turned on, you can kind of easily manage to do that. That is possible nowadays, and we've been seeing a lot of countries and a lot of telecom providers and system integrators taking up that initiative and providing smart home as a service and all of these things to their customers and to the people within the city, right? In telco industry or the telecom industry, we're kind of driving network and operational efficiency, right? With the trends in SDN, NFV, uh, and the latest AI models, a lot of analytics is kind of also helping to see how the network could be managed, how analytics can play a vital role and help the telco providers to serve their customers better. And in short, all of this kind of falls into smart cities. So basically, if all of these elements are working hand in hand, you get a better smart city with efficient and robust traffic systems and all systems working in parallel. So this slide just gives you an overview about how computer vision and AI is trying to change every single market, right? And this change has been happening for quite some time, and this change is here to stay, right? But the solutions might change, and how we respond to things and how we look at things will definitely change and evolve. And I think this should give the young minds who are here on this call to kind of innovate and kind of think about new different solutions and see where there are still gaps. And I'm sure there are certain gaps which needs to be fulfilled, because as and when the new generation comes to work, they see new ways or new styles of working, new ways of operating different things in different scenarios. And since this generation is more technology uh, adaptive, uh, uh, for lack of a better word, they've been used to laptops, PCs, mobile phones throughout the day, so they know how things operate and what they really want out of the device, rather than device giving them the pre-customed or predefined systems or applications or responses. So this generation definitely has the potential to kind of build those future ready devices which they would be willing to use and see how it could benefit uh, their community and the upcoming generations to come. So now, before I kind of dive in to the whole topic, like why OpenVINO and what's been happening, I just want to kind of portray a picture about how deep learning breakthroughs have been. I'm sure most of you might be familiar with this, but this is just a slide for those who are not aware about how the whole deep learning scenario or AI scenario came back again. right? So I'm not sure if you guys had seen a few old movies where they used to talk about this AI, this machine kind of doing or taking certain decisions. It was pretty predominant in the 60s, 1960s and the 70s. And then, and there were pretty much a lot of efforts by different scientists that were being kind of done, right? But then, due to lack of better equipment and a lot of researchers and limitation of codes and all of the other things, it went into kind of the research went into an AI break. That's what I had read, and all of this research kind of came in back starting from the early 2000s, where there was an availability of a lot of good hardware. There were softwares, and people started kind of realizing the true value and true applications of these. And I think the breakthrough started happening post 2010 itself, when some of the developers and people started developing and kind of creating breakthrough applications and breakthrough results with uh, GoogleNet, AlexNet, and all of the other related technologies and topologies, right? You can find all of this history on the internet, right? You can use your favorite search engine and you'll get most of the stuff. But the whole idea is just to show you that the whole percentage of error, right, has dropped significantly from the previous years to the present, right? Because now we have the hardware available, we have the technology, we have the software topologies, we have the optimization frameworks, and it is getting better day by day to kind of get the perfect results or near perfect results for the models which we train using deep learning, right? So as simple as, if you can see the graph on the left, when you talk about image recognition based topologies, right, there used to be an error rate of 30 to 25% or 28% back in the day. And as and when things started getting better, it is now kind of almost below 5 to 8%, which is a pretty great improvement. You kind of look from 2010 to 2020, now it's almost 10 years, right? And also the same case goes with speech recognition as well, right? So similar type of results have been seen, right, in terms of recognizing certain type of voice samples and doing these kind of recognitions. And and when it comes to kind of putting things into perspective, right, you might be thinking, okay, how is this whole deep learning breakthroughs and this image recognition and speech recognition kind of impacting us? What we have seen from different sources and different analysts is that it's going to drive additional economic impact uh, of around $13 trillion, right? This is not some cooked up number. This is a research done by McKinsey. So you can see the link below. Probably when I'll share some of these slides, you can probably go and look at their research, right? And 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 actually it is the way forward. This is what we've been seeing with our customers as well, is nowadays a lot of solutions based on computer vision and AI is kind of being the trend. We're kind of trying to analyze, to get more analytics, to see how to recognize patterns and how to kind of give the best use to, or the best experience to the customer. And moving forward, since most of these microphones and speakerphones are going to go into the mode of IP, and they're going to go IP protocol based, just like the cameras have gone. So we are seeing a lot of great things happening on speech recognition, and on audio generation, and analytics on audio as well, in order to serve customers better, right? So these are the two trends which we've been seeing to grow, and I think this should give a great opportunity to you all present in this call to kind of explore and take it further for your development and for your projects, right? Now, I'll get straight into the point, right? Like, why OpenVINO, and what are the challenges that people have been facing, and why we had to come up with OpenVINO so that it would be easy for everyone, right? And the first and foremost challenge was about the unique inferences, right? When I say this, or let me just back it up a little, right? For people who are still doing computer vision, they know that, okay, some of the models work fantastic on a certain type of hardware. You don't have to do any tweaks and it works right off the box, but that is very rare, right? But most of the times you need to tweak your performance, you need to tweak the model weights, you need to change the heuristic number, certain function needs to be changed, and then you kind of see that, okay, how many codes are being utilized in a particular hardware, how is the parallelism working, how is the multi-threading working, how am I working on these, and as a developer, you need to kind of continuously look into the core of it so that you can deliver the best outcome and best result to your customer or to the application or you're developing at the end, right? And because of all of this, there is always a gap in performance and accuracy between the trained models and deployed models, right? So as I mentioned, train models is something where you kind of train your particular model on a different set of a hardware, right? That is probably of a higher processor. It could be a Xeon processor. You could have trained that whole thing in a cloud or on someone else's computer, or a cloud gaming or a gaming based computer where you thought that, okay, the CPU and the GPU power is high, and let me train that. And but when you take that model and try to run it on your, let's say, Core i5 PC or a Core i3 PC, you don't get that type of a performance. So there's always a gap between a trained model and a deployed model. And you need to understand one thing is that most of the inference or most of the solutions or the application of this computer vision happens at the edge. What I mean by that is, let's say, for example, you're trying to recognize a number plate, right? You have an AI-based application which is deployed with the law enforcement agency, let's say a police department or the national or a federal department, which is responsible for monitoring traffic within the city and kind of issuing fines if a certain car or certain driver doesn't abide by rules, right? So in that scenario, right, uh, the system needs to capture the image, right, and also run that image through different models of license plate recognition, all of these models to see that, okay, proper amount of data is being captured, and that data is useful and can be tagged and can be correlated to different fines and services and other stuff which the police department or the federal department is supposed to do, right? And that happens at the edge. So you can't take the capture, you can't wait for a longer time to kind of get all of that analyzed and then wait for people. And as you know, in a city, right, cars are passing by at like at a very high speed. Like, about a highway speed is about 80 to 100 kilometers an hour, 120 kilometers an hour, and it's just a microsecond or a fraction of a microsecond or a few seconds. So for your data to kind of capture, analyze the model, and give you the results, so that you can kind of tag it to a perfect synergy or the task flow which is being given to the police department or given or assigned by the IT folks of the police department, right? So in order to do that, you need perfectly well deployed models on the edge. By the edge, it means that wherever there's a camera, there is a high-end industrial PC, right, connected to it, which has all of the required software, which has all of the trained models, and it works perfectly fine in tune with the processing power of the system, right? So this is just one example, and this is how the challenge of unique inference needs kind of brought us to bring out Intel OpenVINO Toolkit, right? And moving on, another challenge was integration, right? There was no streamlined way for end-to-end deployment of a workflow, right? By what I mean by that is there were different models that were being used. Some were using OpenCV, there was OpenCL, there are some Python-based models, TensorFlow models, PyTorch, MXNet, and all of those things. And when you try to combine all of these things, right, at times some used to kind of deliver a good performance or the optimum performance which we kind of want from the model to deliver, but then at times when you try to mix and match with different applications, there is no proper integration happening, right? And also there were integration challenges with different cameras or camera streams to the exact hardware, and you're not getting the exact performance in terms of frames per second or getting the exact amount type of metadata to kind of solve your application or serve the purpose of your solution of the demo. So this was also a great one we kind of looked at, and this is also a founding one to kind of bring out OpenVINO. And third one was the most important one was no one size fits all, right? As and when our teams kind of did research and they were working with a lot of our partners and customers and vendors and developers, it's right, they found out there are diverse requirements for different use cases, and each use case requires a unique approach, right? Because you can't take whatever approach you take in a healthcare segment in terms of finding how to find anomalies in a or a heart-based MRI scan and deploy it for smart city application, right? That methodology is different, that workflow is different, uh, topology or the uh, is different, and the hardware is different. The whole approach is completely different, right? So that's why to kind of give all of the benefits, and so that this could be kind of fine-tuned and trained or can be utilized to each and every particular one, should be pretty much unique. So that's why we came out with OpenVINO Toolkit, right? Which kind of uh, gives kind of which kind of gives all of these, like kind of solves all of these challenges and gives you a platform to deploy for your own solution and kind of deploy what you want to do for your particular application, right? And before I dive into what exactly OpenVINO does, what are the components and the technical details, I'll not go too deep technical. You have a lot of YouTube videos for that. I think we have a good playlist of 77 videos, so that whenever you're free, post this session, you can kind of dive into technical stuff, right? I'll give an overview, and I'll also kind of talk about a little bit technological jargons or technical jargons, so that you kind of get interested in what's there underneath the OpenVINO platform or the tool, right? Now, I'll just kind of touch on this point is on the AI compute considerations, right? By now, since I've already talked about all of the different challenges and all of the different use cases, right? You might be wondering, how do you determine the right computing for your AI needs, right? Because if you just kind of have a random idea or a vague idea about the different type of workloads, it's really unique, right? Every workload is different. You have different profiles and all the other things, and the best thing is you need to really identify what your workload profile is, right? Then you also really need to identify your use case requirement, because this is specific. Why I'm talking about these few things in this slide is because I am sure most of you are going to definitely take use of this time and are definitely going to use OpenVINO and the other related computer vision toolkits and try to build your own applications, be it for the Arab IoT Challenge project, or be it for your university projects, or be it for something, or be it for creating a unique product in the market which you would like to launch in the coming months or so. So for that to happen, these are the basics which you need to consider, right? That is, what is your workload profile? What is your use case requirement? Like in the sense that, does your use case require security? Does your use case require scalability? What is the cost factor? What is the power factor? What is the data factor? How are you managing efficiency, manageability, throughput? Does your use case really rely on higher amount of accuracy, right? Or the size or reliability? So that way, you really need to kind of focus on your use case requirements, and also need to see how relevant is AI to your environment, or relevant AI is to your environment, right? Because on that factor itself, you'll kind of be able to plot your utilization to scale ratio about how you're going to utilize your CPU, how you're going to utilize your ASIC or FPGA or GPU in your system, right? So basically, these three are the most important factors to kind of consider for your AI needs, for your application, before kind of even diving and starting to explore different things, right? Why Intel AI compute, right? You get the most out of the foundation for AI from the CPU leader. You can optimize it very well. So you have different options from CPU, GPU, ASICs to FPGAs. You can simplify. You have a software optimized softwares. You have pipelines, a lot of supported analytics and AI, support, and a lot of move and store products available from Intel as well, so that you can utilize that to build your optimized AI platform. And you can lead your industry by aligning with the builder of next gen AI solutions. Now, coming back to our topic, right, and the previous two slides were just to kind of give you an overview on why you need to consider, and now we're just diving into what the whole Intel distribution of OpenVINO Toolkit is, right? So this is basically a tool suite for high performance deep learning inference, right? It's faster, more accurate real world results using high performance AI and computer vision inference deployed into production across Intel architecture from edge to cloud, right? So to simplify in layman terms, right? So it is basically providing you the best results for your trained model or your deployed model on a particular type of edge device, right? So when you use OpenVINO on that application which I just mentioned, which will be used by police or the federal department, that camera-based application, which is connected to the embedded PC. So if there is OpenVINO installed on an embedded PC and you run all of your algorithms and all of the connections to OpenVINO, you will get the best and optimized performance for that particular embedded PC itself. So if it's a Core i5 and you're using, let's say, TensorFlow 1.14 with so and so topology, so and so weights, and a particular camera stream, and you have all of these components, with OpenVINO, it takes care once you run the toolkit and once you run the whole thing, it optimizes your system to run for optimal performance, right? So you get the best high performance from that machine itself. So you don't have to worry about going back into the code base and trying to see, oh, this is optimized or not. How can I make best use of this, and so on and so forth. So all of that is kind of taken care by OpenVINO Toolkit. So three challenges which I mentioned are kind of being easily resolved over here using the OpenVINO Toolkit, right? So you get high performance deep learning inference, you get streamlined development and ease of use. Uh, if you're a regular Linux user, I'll show in the coming slides, and I'll talk about this stuff. So if you're a regular user, a Linux user, so it is pretty easy to navigate. And if you already have prior experience in managing Python-based uh, models and codes, it is pretty simple to navigate and get through this. And the best part of OpenVINO Toolkit is you write once and you deploy anywhere. Once your model is written, once your model is trained, and you can deploy it anywhere and just run OpenVINO Toolkit on top of that, and you'll get the optimal performance. You don't have to worry of going back to change your code for a particular type of Intel-based hardware. Now, coming to applications, right? Because how this is just to show you how the different industries are using OpenVINO Toolkit, right? So they're using to enable safer, smarter, and more efficient industrial applications, right? They're using machine vision with existing infrastructure to kind of see how their equipment is performing. So there's basically the conveyor belts, the robotic arms, the process engineering equipment, to see how it's working well and how they can keep in touch with the existing workflows, right? Also, the reduced need for on-site maintenance and improve uptime, right? And also it gives a heterogeneous flexibility with deep learning, right? So they're combining all of these three aspects and they're kind of addressing uh, better insights and better edge insights and better use cases, better analytics for different industrial use cases, right? And industries vary. Could be from manufacturing sites for rubbers or tires to manufacturing different equipment and so on and so forth, right? So this particularly applies to any industries that is manufacturing high-end goods. For health and life sciences, there are a lot of use cases and applications for improving patient care and enhancing medical diagnosis. Right, with deep learning, it enhances your deep learning with existing infrastructure. Right, improve speed and accuracy of diagnostics, gain better overall patient health. Right, an interesting use case we've done with GE, which is with GE and with Siemens as well. So I'll talk about the Siemens use case. And there's a lot of public information available on the internet, and you can use your preferred browser to kind of search more on it later. So with Siemens Healthliners, we kind of worked to analyze the uh, MRI scan and different anomalies within the heart, right? And we did a kind of side by side, amazing side by side demo or a test run where we saw that if you kind of use an old model of an Intel processor and old topologies, and if you use new model of Intel Xeon second generation scalable processor, the Intel OpenVINO Toolkit, and latest topologies or the Intel optimized TensorFlow and Python topologies, and we kind of varied the whole difference, and the improvement was pretty good enough, right? So we got approximately a 6 times of improvement from running old models on older hardware with no OpenVINO than running models on new hardware with OpenVINO, right? So in the previous, the old system, the performance was coming to approximately 35 to 36 frames per second, right? And with the new we installed it to around 200 to 202 frames per second, right? So it was pretty a good improvement for approximately 5.5 to 6 times, right? And for retail applications, right, OpenVINO is also used for retail applications, and it's kind of compatible with the systems. It helps to kind of do ease of management. It helps kind of enable new use cases with faster time to market and advanced analytics for improved customer service, right? And there are a lot of videos already available. So if you're kind of pretty much keeping track on how people are managing inventory for their retail stores or seeing how the customer interacts, there are a lot of different use cases which are pretty much available, and you can kind of scout through the Intel website. I'm not going to spend much more time on this one. It's just to kind of give you how and where OpenVINO is transforming this. And for safety and security applications, as I had already given you an example, it is kind of scalable with a portfolio of offerings, rapid software development, and industry-leading performance per dollar per watt. Now, how do you deploy deep learning solutions with the OpenVINO toolkit, right? And these are the 3 steps, right? So the first one is build, then second is you optimize, and third is you deploy, right? Pretty simple steps, right? First, you'll always build your models, you train it, then you'll optimize it for that particular hardware, and then third is you will deploy it for the real use case or scenario, right? And this is a much simpler uh, overview, right? Let me just kind of go through this, right? So first, obviously, comes is you take an approach, right? Either you train a model, right? If you're starting new and you're pretty familiar with how the whole training a model to deployment works, so you can train your new model, right? Or if you're not familiar, you can find a trained model. There are a lot of trained models available on the internet. Then you can run the model optimizer, right? And then once you run the model optimizer is part of the OpenVINO toolkit. Once you run the model optimizer, you get 2 intermediate representation files, right? All of your models, all of your trained models, after running through the model optimizer, are converted into an intermediate representation file. That is 2 files. One is a .bin file and another is a .xml file, right? And these 2 files then kind of go ahead to be deployed using the inference engine. And once that's done, you can then deploy it to any of these platforms. It could be a Xeon-based server on an edge server, or it could be a core-based industrial PC or an Atom-based device, or it could be including, it could be an ARIA 10-based FPGA, right? So this is a simple process. You either find a model or train a model, run it through the model optimizer. You get .bin and .xml files, and then you deploy using the inference engine on the preferred choice of your hardware, right? And, and there are a breadth of supported frameworks that helps you to maximize development, right? And and for the people who are familiar and for not, OpenVINO supports most of the industry standard frameworks, right? You have TensorFlow, Caffe, MXNet, Caldi, ONNX, Caffe2, Chainer, Keras, MATLAB, Paddle, PyTorch, Siemens. And an interesting thing is our software teams work closely with TensorFlow, Caffe, and most of these platforms to develop Intel optimized TensorFlow frameworks, right? So whatever frameworks you see on the TensorFlow website, I think now it's 2.0, and you'll see, and if you deploy it for any other application, it works fine. But then we have a special optimized versions for Intel hardware. Like if you're talking on deploying TensorFlow frameworks for training something on Intel Xeons, you have those optimized libraries and those supported frameworks, which kind of help you to train your model much faster and much more efficiently on an Intel-based hardware. Now, kind of taking the step from optimization to your deployment, right? So basically you have the model optimizer, which I said, it's a Python-based tool to import trained models and to convert them into an intermediate representation. Then it optimizes for performance of space with the conservative topology transformations, and it is a hardware agnostic optimization, right? And then you kind of pass it on to your inference engine, which is high level C++ or Python based inference API, and then it delivers the best performance for each type without requiring users to implement and maintain multiple code pathways, right? So I know I've not gone too detailed. I've just given you kind of a high level overview and how OpenVINO works and operates, so that it's easy for most of the audience to understand the whole flow. And don't worry about it. There are a lot of videos. I'll be sharing you links so that those who you are interested and really need to understand from the scratch, from the basics, there is a lot of tutorials available on YouTube publicly so that they can feel free to use that, right? And coming back to the point of write once and deploy anywhere. So it's basically giving you the cross-platform flexibility, right? So you can uh, write once, deploy across different platforms with the same API and framework independent execution. No need, get consistent accuracy and performance across all target devices with no retraining, right? And you can do this from devices from your edge all the way up to the cloud, right? And there are a lot of tools to speed up the test cycles, right? So you have post-training tools, optimization tools, you have deployment manager, you have the benchmark app, you have the accuracy checker, you have the model downloader. So these are the 4 or 5 tools which help you to kind of enhance your computer vision based or AI based models while using OpenVINO, right? And most of you who are already using, you might be knowing the importance of reducing the model size into low precision data types and how it kind of affects performance and how do you kind of get the best performance with a smaller footprint compared to a development package, and why or how the accuracy checker really matters for those kind of applications. So you have these 5 tools also available, so to kind of easily help you with the or speed up your test cycles and development with OpenVINO. Now, I'm done talking about the OpenVINO, right? And might be wondering, how do you kind of use this and access it, right? Because now everybody is sitting at their home. They really need to kind of test it out and see if it is really the right tool for their use case or their application. So what we've done is, before everybody was kind of gotten into this situation, we already had a program where we are working with the partners to deploy a cloud-based service where all of this Intel hardware is available, all of this software codes are available, and it is easy for a person to kind of just log in through their web browser on their PC, get access to these pre-installed systems, they can test it, and if they really want to kind of build something new, they can get access for that. So the next two slides, I'll be talking about that capability, and that capability is called Intel DevCloud, right? And as I mentioned, we saw a few of the industry challenges previously, right, where we were seeing that customers and partners were kind of going into a hardware and software choice paralysis because there was a lot of available hardware in the market and there's a lot of software available, right? So they don't know what to choose, how to choose, and where to start, right? And also there was a lot of outdated technology in the market, right? Because there are so many models that are kind of coming up. Some gets updated 2 months, 3 months, or the update cycle is 6 months to a year. So you really don't know which one to use, what to use, and how to kind of keep all of these updated. And at times, the most fundamental thing is not sure where to start and what performance benchmarking to use, right? So the left-hand side, as I mentioned, all of these 4 or 5 challenges, Intel DevCloud tries to kind of address those challenges, right? And it provides you a complete toolkit of optimized hardware and software to instantly equip developers with best technology, right? You have immediate access to the latest hardware. You have latest version of Intel and the compatible edge hardware already deployed in the cloud, right? And for performance benchmarking, you can receive hyper customized performance benchmarks in an easy to compare side-by-side format, right? So there are also videos, don't worry about it, on YouTube, so you can kind of access these, and I'm gonna talk more in the next slide. So basically, how the whole DevCloud works is you get instant global access. You can run AI applications from anywhere in the world. So I'll be sharing the sign up link with Mohammed post the session so that you can sign up, right, with the instructions. And I'll just kind of take you through the process of how the whole thing works, right? And basically, once you sign up, you get your account, you get your username, you get a password. Through your web browser, you get the HTTP request. Then you get access through Jupyter Notebook, where you have pre-trained models. You have certain object recognition and workshops and toolkits and sample projects already available and built in the Jupyter Notebook. And if you're not familiar with the Jupyter Notebook, it is a simplified space where you can run your code line by line and see how it kind of works on a particular type of hardware. And then you can kind of completely also run your full code as well. So with the help of Jupyter Notebook, you can get guided step-by-step way of deploying an application, right? And once you kind of deploy it on your servers, you get approximately 50 GB of storage space to kind of store your video streams and images. And you can then create your job queues, right? In terms of what application or what system you want to kind of put it in the queue, and then you kind of deploy it on the CPU, FPGA, GPU, or VPU, and then get the final inference image or video or the output from the image, right? And then once you've got that thing, you can kind of put it back into the results and then start the whole process over and again, depending upon your use case or your application, right? So this is just this kind of a simplified version of the process over here in the image, and the whole idea is you can prototype on the latest hardware and software, right? Develop knowing that you're using the latest Intel technology, right? You can benchmark your customized AI application, immediate feedback, frames per second, performance, and a reduced time, reduced development time and cost, right? So you can easily find the right compute for your red solution. So it becomes very simple for you as a developer to find your way through the dev cloud, understand what available hardware is there. You can test it through the available samples and see if you really, if all of these things are useful. The catch over here, this is available for developers 30 days only. After you sign up, you get your username and password. And the great thing is we have kept it free, right? So I'll share the link. You can sign up and then you can make use of the latest Intel hardware and the OpenVINO optimization to kind of create your application, right? So you don't have to worry about any type of hardware, what software topology should I use, what is the best framework, and stuff like that. Everything is, you can use the pre-installed versions, or you can kind of select and mix and match what you really want to choose as your hardware base and what type of topology framework and what type of version you really want to use. And then you can start building your own application, and that application could be useful for presenting at the Arab IoT and AI challenge in the upcoming hackathon. So that's it from my end, right? So it's basically you're combining both DevCloud for the edge and OpenVINO, and this is the link. So if anybody is there on their PCs or phone, they can kind of take a screenshot of this, and then they can kind of access it from the choice of their favorite browser and go ahead with it. I'll be sharing these links and other related videos and a document for you all to explore different type of use cases, uh, post this copy, etc., so that you can have an idea to create different type of applications. So that's it from my end, and I think we're almost at the end of the session. So thank you very much, Mohammed, and thank you everyone for patiently listening. And now I think we'll take some questions. Mohammed, over to you.
Yes, I can hear you. We can wait for a couple of minutes. So if anyone has any questions to write in the chat.
Sure. So I just had this extra slide put in, right? For
There is a question from Bassam.
yeah, sure. Please go ahead.
Bassam is asking about the presentation.
I can share a PDF version of the presentation, and then you can share it later with the teams.
Okay. I will get the PowerPoint from Baghwan and I will share it with you via mail with the feedback form we will share with you after the webinar.
Sure. I can see one question from Ahmed Morsi from Egypt.
Yes.
Yes, we are using all Intel products, right? So on DevCloud, you have products from Core i5 processors to Core i7 to Xeons, and all Intel optimized frameworks of TensorFlow, Caffe, and the Intel OpenVINO Toolkit. Cool. So I think just to wrap up, since we don't have much questions coming up, I'll wait for a minute. And before that, I'll kind of talk through this slide over here, right? And as I mentioned, right, the simple workflow, this is just much more kind of an open version of the workflow, right? Really, how do you kind of run it through if you kind of get through certain errors, or if you want to work through your customized layers or something. So I'll start from the beginning, right? So you basically create a plan, determine the model type, the framework needed for your usage. Then you find a model, build a model, and then you kind of train it, and then you modify it, tune it. And then during the modifying and post training, you can kind of check for the error codes. And if you really want to kind of recommend custom layers, you can create custom layers. If you don't want, then you can kind of go in a different workflow. So this workflow kind of gives you a clear or a much clearer idea on how you want to kind of deploy your AI modules uh, uh, for your application, and how you can use it with the OpenVINO toolkit. Cool.
I think a couple of people are asking about a training path for working in AI. I think Intel is having online courses for free for this track, right?
Right. So we have one course on. I'll share that course. I think it's on Udemy, on the OpenVINO toolkit, so they can get trained and kind of probably get a certificate after this, because that's sponsored by Udemy. Like, depending upon terms and conditions what Udemy has for course completion. So that's there. And we also have certain courses on our website called software.intel.com, right? So we have different basic courses from machine learning to statistical learning. Then we have high level courses called Deep Learning 501, AI 501, and then speech recognition and all those technical aspects as well.
There is a question from Ahmed Morsi. He's asking about, so if I train the model, it could work on FPGA or CPU without modification?
Yes. So for this, you need to kind of test it out on the DevCloud, right? So, and optimize it using OpenVINO. Then you can kind of run it on it with FPGA and with CPU or a combination of both. You need to really have the bin file and the XML file to see that you're safe with all of the usages. VPU. Okay, so let me answer Mustafa El Hosseini's question. Yeah. VPU is visual processing unit. So we have something called a Movidius VPU, which is giving you that added performance for inference needs, right? So it's basically a small M.2 electronic device, which is M.2 compatible, right? Which you just plug into your any M.2 slot available in your PC, and you can transfer your some of your workloads or stream workloads from the CPU to this VPU, right? VPU is not that powerful. It has a very low power consumption, but it is usually used in edge devices where you have a lot of repetitive images to kind of process, right? So if you have an application where you're kind of capturing a lot of images, and the best example is you're doing license plate recognition, right? There's a camera sitting somewhere in the highway and you have a lot of these happening, and you really don't want to overload your CPU because you know that your system is doing one kind of a job every second, few seconds and forth. So you can transfer some of these microcodes and design an architecture in such a way that your inferencing can happen on a combination of a CPU and a VPU, so that your CPU can, some of the codes and some of the threads can remain free for other applications to be performed on the CPU. Difference between OpenCV and OpenVINO. So OpenVINO includes all of the OpenCV protocols and the models, right? OpenVINO is a toolkit, right? It's built by Intel to give you optimized performance for Intel-based hardware. Performance compared to VPU and GPU, it's different, right? Because VPU comes in different factors, right? You have a 2 Movidius VPU, you have a 4 Movidius VPU, you have an 8 Movidius VPU, and you have an array of products in the VPU form factor, and then you have an array of products in GPU, right? And if you talk about comparing VPU to GPU, you're basically comparing apples to oranges, right? Both have a different type of an architecture. Both try to kind of serve a different purpose in terms of giving you the best output for your images. Yes, can we use PyTorch? Yes, PyTorch is available on the Intel DevCloud Edge, and if you are really want to use OpenVINO, you can use it with OpenVINO as well. I'm not sure about the scholarship on Nano Degree with Udacity. I really need to check on this one. Thanks for letting me know this error. This is the first time I'm hearing the error on the Intel website for machine learning. Usually it's pretty simple, it works. Once you need to sign up for that, and once you're signed up, you get direct access to the course and you have all of the PDFs that come in.
I had this comment from Maha Hussein too, Baghwan. She was writing to me in the private chat that she registered on the Intel platform, but she can't enter the course itself.
Yeah, so you need to wait for the official email. Like once you register it, you need to wait for at least few hours. And since a lot of our folks are kind of trying to catch up with the whole remote working, and a lot of requests are coming in, so please expect around 24-hour to 48-hour support time frame. Access and credentials, you can probably then log in again and try to access those courses.
Okay.
Is the case for Intel DevCloud. Try to be patient with us, right? I'll share the links. You can sign up, but then please wait for 24 to 48 hours before you get your username and password. Once you get username and password, then you can navigate through the site, sign in, and then there are step-by-step tutorials on how you can start about it.
Okay. A last question for Muhammad Namdou.
I'm not quite getting the question over here.
He's asking about the national IDs and passport. In these official documents, you have small photos for the person.
Mhm.
Are these photos are good enough for the machine to detect the person?
Right. So usually, okay, so there's a national ID involved. Usually when these check-ins happen, right, there is usually a camera where the person is standing in front of, and then you have already available images, that high-res images in the system. You don't usually kind of take the image which is there on the ID card, right? So if there is a correlation between the feed that is coming from live feed from the camera and from the database which has that image, that is a pretty mature use case, and the matching occurs easily. But I haven't seen people using photos, that small photo from the ID to match the person. Cool. Cool. Okay, I think we're done with the questions, and I think we are on top of the hour as well.
Yeah.
So it was a pleasure talking to you guys, and I hope it was useful. I know some of the topics were pretty fast, but I had to cover a lot within the hour. And I'll be sharing the slides so you can kind of go through it. I'll be also sharing one document which we released recently for our partners and customers, which gives an idea on how to kind of think on new technologies post the COVID world, right? So that will also be useful for some of the participants who are participating in the upcoming Arab IoT and AI pandemic hackathon. And I'll be sharing the links for the Intel DevCloud registration, a small YouTube video on how to operate that, and the related stuff. So Mohammed, I'll be sharing these details in the
Yes.
next 15-20 minutes, so you can convey it to the participants accordingly.
I will be sharing it with all of them. And let me give a final note here.
Tell our participants about the Arab IoT and AI Challenge. It's a regional competition happening in Egypt, Tunisia, Jordan, Palestine, and Emirates. You can join it from your local country, and we have partners like Intel, Amazon, Google, Nokia, and they support us with different stuff like this webinar and free access to their paid services, cloud services. Also, Intel is supporting us with different kits. You can use them for processing units for machine learning and artificial intelligence applications. We have tracks for graduation projects and startups, and you can apply through the website. There is you can apply. Bassam is from USA and he is Egyptian. You can apply as Egypt as an Egyptian applicant, and you can join the process, inshallah. The name is Arab IoT and AI Challenge, and it's a yearly competition. It happens in local countries, and then the first three winners from each country join the finals in Dubai. You can just write Arab IoT and AI Challenge in any platform, and you can reach us directly. Thank you so much, Bagwan, for this session.
Thank you, everyone. Thank you, Mohammed, for this platform, and I wish everybody stays safe, and we'll get through these complex times.
Thank you so much.
Thank
Thank
you.
you
Pleasure.
to all our participants who joined in Ramadan and this not very well circumstances around the world, and they are eager to know. I really appreciate this, and I really support this so much. Wish you all the best. I pasted the links to the competition And I'm looking forward to meeting you soon in other webinars and in the competition itself. Thank you so much.
Happy weekend and Eid Mubarak in advance to everyone.
Thank you.
Thank you.